So it's important to know whether or not you have the right clearance between the cam and the bore. It's supposed to be about 3/1000ths, and if it's too much, you have to do something about it. You can't just run it that way. There's nothing in the manual about exactly how to do this, and that's what I try to record on these YouTube videos, is stuff that's just, I can't just go right to the manual and look for. So if you want that kind of information, please subscribe and like the video. Make any comments of things that you know, machine shops that do this, a good job with this. Anyway, we're going to get into today how to figure out whether or not we have the proper clearance, whether or not that bore for the cam is good to go, or we have to install bearings. But what I'm finding out is the cam bearing installation is very expensive. So although this is just bare metal, and it looks like the cam just rides in the block, they've actually case hardened this metal right here, so it's very hard. So this is a good bearing surface. Now that's good for a bearing, but it's bad for rebuilding or line boring because that metal is so hard, it's very hard to cut that. So, and not every machine shop will even know what you're talking about to cut these, and won't be set up to cut them. I talked to one machine shop that knows these engines, and they say it takes him, he's all set up to do it, he does it. It takes 7.5 to 8 hours with attended machine time to cut these bearings, to cut this for bearings. Now, times $100 an hour, that's $700-800. That's expensive. I'll share the link for this. I did find a machine shop that had put on the YouTube a video of line boring the cam bearings and doing it the right way. You notice he's got it goes all the way through, so he's not doing it from one side then the other. He's got a great machine, so so I don't know if it's legal.
But anyway, here's the setup, and I'm going to take a cut. You have to take several cuts because you're taking a lot out, and this is about a 25/1000th cut that I'll be taking. Now here's the well, it shows up. That's the cutter. You can just see I've got a high positive carbide insert in there, which gives us.
So you get the idea, and I would encourage you strongly to go and watch this video on YouTube. I'll put the link in. Come on.
Because of
the name of the site is
you really can't do it.
Motion 24.
Anyway, here's the setup, and I'm going to take a cut. You have to take several cuts.
So what are the disadvantages of leaving this out of spec or too big? Well, one is your cam is going to flop a little bit, right? Secondly, oil pressure is determined by that clearance as well. And if this has too much clearance, you're going to lose some oil pressure. So that's why some people have said, hey, I can get a whole new block that's in spec, or a used block that's in spec for a few $100s. I'll just trash my old block if this is out of spec. So today we're going to measure this, and we're going to figure out where we're at. Are we in spec? Do we have to trash this block? What are our choices? Where do we go from here? So let's get started on that. So in trying to figure this out, first thing I did was went to the manual and look at the specifications for the cam journal diameter. It is supposed to be 1.8402 to 1.8407. So first thing we need to do is measure the journal diameter on the cam, and we did this with a 2-inch micrometer. Most people have a 1-inch micrometer. You need a 2. You can get these on eBay if you're careful for $40 used. I like stare it. So anyway, you do need to make sure you get one that'll go to the 10,000ths. These lines here show to the 10,000th. Watch the other video on evaluating the cam for wear if you want to know more about what we learned about, relearned about micrometer use. But anyway, you take it at a couple different places on the journal, and I did this, and I have And I got 1.8404, 1.8404, 1.8403, 1.8403, 1.8406. Were the diameters here. Those are in spec. Again, look at the other video to see about evaluating cam wear. So now that we have the journal amount, we need to find out what the bore diameter itself is, because really what we're after is the clearance. There's the bore diameter, how big the hole is. There's the journal diameter, so you subtract the journal diameter and you get the clearance. We do have a specification for the clearance. It's not in the regular Bentley manual. I did find it in the Haynes at 0.0026 to 0.0046, or roughly 3 thousandths. Around 3 thousandths is the clearance you want for most of our bearings anyway. So what we need to do now is measure the bore for 1, 2, 3, 4, and 5. Measure the bore and subtract the journal diameter from that to get our clearance. So we're going to do that next. Now here's the dial bore gauge. It's important to get one that'll be in the range. The cheaper ones are 2" to 6". This is a little bit more, and it's 1.4 to 6. So what we do is we take one of these anvils, which in this case we're going to go with the 1.8 anvil, and we put it in here. And then there's these washers, these spacer washers, and those go under this cap, and in order to and they lift this anvil up by 0.040. So I have a couple more engines to rebuild. That's why I bought this. Well, actually, it was a happy birthday to me. Never used one before, so it was a learning experience for me. And I put the thing together the wrong way around. Before, I thought you might want to see how this works. So here's the anvil. And then you don't put it on this side, as I learned. Couldn't figure out what I was doing wrong. You put it on this side so that you got your 1.8 inches, and this adds 40 thou to it. And you put it on, and you assemble it like that. Pretty easy once you figure it out. Oh, by the way, this is a Fowler. The research I did showed this is pretty much the best one for the money without going crazy on the price. So here we go. We're gonna set that up, and I've got soft jaws underneath the towel, the microfiber towel there. So I'll go a little bit this way. That's my maximum point down around 6 o'clock, and I go a little bit side to side. It's also around 6 o'clock. So what I'm going to do is I'm going to take my 0 and I'm going to move it down to a little bit past 6 o'clock and see where we are. So where a helper would be nice. And we're going to 0 it out. There we go. So now we're all zeroed out, and everything I measure now I can add to that 1.840, because it'll be, as the bore gets bigger, this will move to the right. In other words, we're going to measure it this way vertically and this way horizontally. This is the front of the engine with the water jacket and the water pump attachment holes here. So we're going to go ahead and measure it, and it's most likely, because the cam gravity goes this way and the cam is pushing on it this way, the bore should be bigger this way than this way. So let's take a look and see what we've got. Turn that a little bit so you can see it. Okay. And horizontally, it is plus 4.5. I'm going to go 0.00045. Vertically, I know you can't see this, we see we're going to be plus 5.5. 0.00055. That's number one. If I try to get it to reach down to the next bearing, Houston, we have a problem. That's not going to go. So we're going to have to let number 3 just be by faith. Okay, I put just the vertical bore measurements here because the vertical bore was bigger than the horizontal bore. So I moved it 1.8455. So we subtract this out and we get 15005. We subtract this one out, we get 15000. We don't know what number 3 is. We could use the telescoping bore gauge, but I don't have any. I actually have some on order. I got to order some on eBay today, some used ones that were that looked like they were in very good shape. Starretts, I like Starrett. So 10 minus 3 is 7. That's 6, 0, 0. And then we have 5 minus 6 is 9, 4, 0. Okay, so our clearance specification is 0.0026 to 0.0046, and we see that all of them are out of spec. This one's out by, 5/10 thousandths. This one's out by 5/10 thousandths approximately. We don't know on this one. This one's out really a lot. This one's out by 21. It's out by 0.0021, so that's really bad. And then this one's out by a little bit less. I'm wondering, why is this one more worn? I'm wondering if it has to do with the fact that the gear and the fuel pump lobe are right on this one, so maybe this one gets a little bit more load with all of that going on with that one. So I think what we've decided is our bore is out of spec and it's a little bit big, and we're going to lose oil pressure that way. I'm probably going to go to a little bit hotter cam, and the hotter cam is going to put more pressure on these bearings because it has these lobes are bigger, so it'll push down more. Because I'm going to go to a little bit hotter cam, I think I'm going to go ahead and put cam bearings in this engine block. I'm not going to mess around. Anyway, so we've evaluated our cam bore wear. We've come to a conclusion, and I called the machine shop, and they're just waiting for me to show up with the engine block and the bearings, because they are also going to install the cam bearings for me at the same time. I'm not going to bother to buy the installation tool for cam bearings at this point. Maybe next time I go up to my son-in-law's house, we'll play on his lathe and make some out of some chunks of aluminum he has. Anyway, thank you for watching, and if this was interesting, please subscribe. It encourages me. If you saw something I did wrong, let me know. My goal on these is when something's not in the manual, I try to document it both for myself later so that I'll remember how I did it, and also, hey, it might help somebody else who's chasing down, like trying to find the clearance numbers that weren't in the Bentley, or exactly how does this all work. So I hope it was helpful. Thank you.